Traditionally, when we're doing vibration tests, we install accelerometers connected to big fat battery packs, data loggers, and laptops. And we run long wires to connect to the sensors over here. As you can see, this is a traditional sensor. We're doing all this setup and booking the entire train, as you can see over here, just to do a very small test. Wastes a lot of money and manpower as well. How do we solve these resource problems? We integrate the entire system of components into a very small, tiny device called vSensor. Now, instead of booking the entire train and connecting to multiple components on this train, attach the vSensor underneath the chair and run the sensor measurements during passenger service time, which saves us a lot of resource.
Installing the vSensor.
So I'm going to apply some Loctite behind the sensor. Just a bit of Loctite should be fine, it's very sticky.
You can install it anywhere on the train saloon, on the bogie, on overhead line pillars, and even on the railway track near the plinths. But it is highly recommended to use strap ties for dynamically moving components, or simply for redundant security.
Operating the sensor.
So all you have to do is insert the micro SD card, flick on the switch, press the button to remove gravity offset, and don't forget to record down the date, time in hours, minutes, and seconds. The recording starts immediately using the following default settings, which are 3 milliseconds sampling rate. Both 2G and 100G force sensors are enabled, and they measure 3 axes of vibration simultaneously. And the batteries would last for around 27 hours just using standard AAA batteries.
Changing settings.
But if you want to modify the default settings, just simply go inside the SD card. You'll see a number of files here. For example, if you want to increase the sampling rate, double-click on period and change the default setting of 3 milliseconds to 1 milliseconds, which is the fastest speed of the sensor, 1000 Hz. Now, normally 3 milliseconds is sufficient for all applications, which creates around 2 gigabytes of data within 24 hours. So I'm just going to press File, Save and Exit. Now secondly, if you want to change the maximum range of the sensor, double-click on Range and change the default setting of 2Gs to 16Gs, which basically increases the measurement range but decreases the accuracy of the sensor. Now the 2G sensor is suitable for train saloon measurements. The 16G sensor is normally used for axle box measurements or any train component below the primary suspension. And the 100G sensor is suitable for train tracks.
Data analysis.
So after you conducted the test, you get a whole heap of data, as you can see, in the format of V1, V1.1, 1.2, 1.3, etc. And remember that every time you press the sensor button, the file name number jumps up by 1 number to V2, and if you press the button again, it goes to V3, V4, etc. Now open up your vSensor Expert software. Basically, press Update to load your datasets. And we have fresh new data coming from MLR train connected to a Seoul bar at the East Rail Line. Now, select the very first file containing your whole dataset. So that's V6 in this case. And I'll select 2G because the sensor was connected inside the train saloon. We want low range G-force. And the whole entire dataset would load automatically into your system. That's 177 megabytes in 5 seconds. So as you can see, the analysis has already been conducted for us. This is the power spectrum analysis on the vertical Z-axis. Now, as you can see, the dominant vibration is at 100 Hz. And as we know, the vibration on train tracks usually at 2 Hz and 4 to 6 Hz. So 100 Hz vibration usually means the vibration is coming from a compressor or a motor equipment. But let's take a look at the back over here. We have the X, Y and Z axis have been plotted. But for our case, the X and Y axis have been reversed. X means the longitudinal vibration towards the train motion, and Y is the lateral and Z is the vertical vibration. So they were reversed, these two. Now, as you can see, the analysis has already been done. We get the peak vibration for all the graphs, as well as the root mean squared over here. Now, do you notice that there is a lot of dwell time? And the dwell time, which means the train has been stationary for a long period of time, would affect the root mean squared value. So we have to get rid of those. So the way to do that usually is we select the beginning region and the ending region of analysis, and the plots would plot that region only and ignore those dwell times. There are other things you can actually do. You can zoom in and zoom out using these tools over here. Just draw a window and it would magnify for you. So that's it, basic analysis. But don't forget that this does not only apply to trains, but also to train tracks or even chiller systems, for instance. But what if you want to do more analysis? For example, compare your data with international standards. You can do that by pressing criteria to set your analysis criteria. For example, the vertical journey average, we want it to be within 0.01 of a G. Well, you basically set these limits and press save and then quit, file, close. Press global analysis or select a region that you want to analyze, and basically the right hand side table would basically update. It would update your limits and compare it with your results. What if you wanted to do station to station analysis? Well, that's easy too. Just click on train station selector, press update, and basically the software automatically detects your train stations based on the x-axis train deceleration rates. But sometimes we need to help the auto detection. As you can see, there are too many train stops detected. So select train station dwell, which basically select the dwell time. You can also change the minimum station dwell time to 30 seconds, change to 20 seconds for example. Press update again, and as you can see, it's pretty good. The train stations have been detected at the dwell times, but there are too many of them. Sometimes you can just simply delete them using this tool on the right hand side. But for the case if you were inside the train timing the train stations by yourself, you can actually do this manually. So I'll just clear all the stations first and basically set the start time of when you turned on the sensor, which is 2nd of March 2005, 12:21 PM, 02 seconds. Press close, and the start time has been defined over here. Next, we want to define the station arrival times. For instance, we arrived in the Mongkok East at 12:54:30 AM. So press add station. We select March the 2nd, 12:54:30 AM. Press close, and station number 1 has been defined already, as you can see. Next, you can actually add more points, more station points by pressing add point. Let's say there's a station over here, or a station over here. And the easiest way to do station to station analysis is to simply select your regions. For example, I want to measure the vibration from station number 1 to station number 2. The left hand side of the graphs would update as such, as you can see, including the power spectrum analysis. But if you have too much dwell time in your data, for example, around 50% of this data time is dwell time, which means your RMS calculation is not going to be accurate or reflective of your actual vibration data. So what you're going to have to do is remove the dwell time. The easy way to do this is press trim dwell. Press yes, and the dwell time will be removed, as you can see. Press yes again. Now you can select your regions again, and the RMS would be reflective of only the data without dwell. And lastly, if you are as lazy as me and you need to do station-to-station analysis, why don't just press a button? Go to the menu and you can see different types of reports you can choose from. The ride comfort report, train component analysis report, or even the track measurement report, depending on the case. But the sensor must be installed on the train, either inside the train saloon, on the bogie, or on the axle box, or anything like that. But remember, you need to select the region first, so let's do that. We want to select between Station 1 and Station 3. And now select the report that you want. For our case, it is train component of the sol bar, so let's do that. And then press Update. A bunch of graphs would actually pop up, and just simply wait until the report is completely compiled. So the Word file will be generated down below, so let's click on it and see what's inside. We can see there is a table of contents being generated, and below there is an executive summary with a table of vibrations from locations 1 to 2, locations 2 to 3, etc., ranked from the lowest vibration to the highest vibration. You could also fill in the test dates, the test trains, and add your own photographs as well. And of course, the most important is the total journey analysis vibration being calculated with all the graphs, including the Z, Y, and X axis, along with your power spectrum graph. And if you scroll down below, you can see the station-to-station analysis graphs from location 1 to 2 and 2 to 3. That's pretty much it. And last but not least, remember to save your file as a doc file, not a docx.
Multi-sensor analysis.
Before we go, we would like to show you how to do multiple sensor analysis. Now, if you have multiple sensors connected to different positions of the train, but you want to plot those vibration graphs on the same time scale, well, this is what you do. You put your vibration data into separate folders, but name them by their, for example, position. Here we have Kingpin and Sol bar. Let's double click on Kingpin and see what's inside. We have the data over here, but we're going to add one file called timestart.xlsx into this folder. Double click on timestart. Opens up Excel, and in the very first cell, change the A1 cell to the start time of your sensor. So let's say it was March the 2nd, 2005. The start time was 12:20:19 p.m. And get back into your vSensor Expert software. Now click on Batch Mode and Report Generation Multi-Sensor. Press Update. And it will ask you ensure you have placed your sensor data into named folders. Next, select the directory to generate your report file. OK. Select the 2G sensor that we need. And we're going to select the time interval that we want to do the analysis on. For instance, if I want to measure the time between 12:22 to 12:50, well, we select the date was March the 2nd, 12:22, close. Now select March 2nd, 12:50, close. Select your folder containing your data, which is here. The Kingpin and Sol bar data is inside this folder. Press Select Folder. It would remind you to have your timestart.xlsx in each folder. Press Yes. And it would automatically do some calculations. And you can open up the Word file at the bottom of the screen. As you can see, this is the Multiple Sensor Vibration Assessment Report, with table of contents and executive summary. And inside the executive summary, you can see it compares the Sol bar and Kingpin vibrations from the X, Y, and Z axes. In the setup section, you can fill in the test date, the test trains, and some photographs as well. And plots the Kingpin vibration analysis graphs, as well as the Sol bar vibration analysis graphs on the same timescale. So that's it. And if you want to know more about the vSensor, feel free to click the link below for the full manual, the calibration method ways to format the SD card on site. And have a nice day.
Goodbye.